Welcome everyone to Amazon Web Services webcast introducing Amazon Kinesis Firehose. Before we begin, I would like to walk the audience through a few items. On your screen, you can see a Q&A pod. Please submit your questions for our presenter at any time. Our moderator will answer them throughout this presentation, and we will also have a few times in the end to have the live Q&A. At the end of this presentation, we also have 3 poll questions. Please feel free to provide us your feedback. Today's webcast is being recorded. We will send you a follow-up email with a URL to the recording once we verify the recording quality, as well as a link to the presentation deck. And again, welcome to today's webinar, Introducing Amazon Kinesis Firehose. Our presenter is Adi Krishnan, Principal Product Manager at AWS. Adi, as the product manager for Amazon Kinesis, the services that makes it easy to work with real-time streaming data in Amazon Cloud. Adi loves spending time with customers and partners to define products that delight and deliver value. The rest of his time is spent helping build, prioritize, and manage fast-growing business. Most of all, he enjoys talking technology and what it can do for people in the long term. At AWS, Adi helped launch the original Amazon Kinesis product, and a prior life helped product management roles at Microsoft, where he worked as the Bing search engine, Azure, and high-performance computing division. Today with us, we also have Praveen Gatu, the Software Development Manager. Praveen will engage with you and answer your questions throughout the presentation while Adi presents. Well, Adi, welcome, and now pass the floor to you.
Thank you. And thank you, everybody, for joining Praveen and I today to learn a little bit more about the newest addition to the Amazon Kinesis platform, Amazon Kinesis Firehose. So in today's session, we'll go over some of the key concepts surrounding the usage of Amazon Kinesis Firehose. We'll then dive deep into the experience for delivering data into S3 and into Redshift, along with the key patterns and practices that you should bear in mind. We will also cover the Amazon Kinesis agent that makes it easy to perform best practices puts into Amazon Kinesis Firehose. And we'll cover off the key APIs in an overview section. We'll also spend time talking about how to troubleshoot your fire hoses in cases of erroneous situations. Just as a very high-level introduction, Amazon Kinesis platform makes it easy to capture, deliver, and process real-time data streams on AWS. The platform makes it easy to provision, deploy, and manage the right resources for the right job. The services themselves are elastically scalable with varying degrees of control that you as developers, architects, DevOps, and system administrators can then exert. Kinesis operates in real-time and near real-time latencies, and at its core provides a pay-as-you-go model with no upfront costs. Amazon Kinesis Firehose makes it easy to load massive volumes of streaming data into Amazon S3 and Amazon Redshift. Firehose is a zero administration platform, by which we mean that there is no application to write or no infrastructure or resources to explicitly manage. Firehose enables a direct to data store integration, by which we mean Firehose performs best practices loading of data into Amazon S3 and into Amazon Redshift by exposing easy-to-use configurations that you can simply configure, change at any point in time without worrying about how the data delivery actually happens. Firehose enables batching, compression, and encryption of the streaming data as it is delivered into these destinations. And finally, one of the key value propositions for Firehose is that it scales elastically and seamlessly to match your incoming data volumes and throughputs without requiring any explicit intervention from your side. So let's look into the overall Firehose customer experience. There are three simple concepts surrounding Firehose. The primary concept is an entity called the delivery stream. You create a delivery stream attached to a specified destination and you send data to this delivery stream. So the delivery stream is a fully managed resource that is responsible for capturing and then loading the data into S3 and or Redshift. The key thing here is that there are no additional resources or infrastructure that you need to create, and there are no additional constructs related to partitioning and scaling of data that you need to worry about. Data that is put into the delivery stream is called a record. Data can be sent from your infrastructure running on EC2 instances, say, on AWS. The data can come from mobile devices, but regardless of the data producer itself, the data blob that is emitted and captured by the underlying delivery stream is treated as a blob and can be as large as 1,000 kilobytes into any given delivery stream. The different data producers themselves or the sources of data are what we refer to as data producers. So at a high level, these are really the only key constructs that you need to be aware of as you start your journey with streaming data on Firehose. You will find Firehose within the Amazon Kinesis console on the AWS Management Console. You'll notice that when you click on the Kinesis console, you're taken to a unified experience for both the Kinesis Streams offering as well as Amazon Kinesis Firehose. When you click on Kinesis Firehose, you see the three key benefits, but really what you want to do is get started by creating the delivery stream. Once you create the delivery stream, the Firehose experience for S3 comes online so that you can then determine what it means to create your specific fully managed delivery experience for capturing and delivering streaming data without having to build an application. You'll notice that the first thing you do is that you specify the destination, S3 or Redshift. Here we showcase S3 as a destination, and the console requests you to input a specific delivery stream name, as well as provide the name of the S3 bucket that you wish to capture data into. You can also optionally specify a prefix, and we'll talk about how the prefix changes the naming pattern of the S3 objects as they're delivered. The last required field in the console is that of specifying an IAM role. So these are the permissions that you grant the underlying delivery stream to access the specified S3 bucket to load data into. There are some additional configurations that you can perform right here on the console. Specifically, you can specify buffering hints both in terms of size and in terms of interval, and optionally, you can specify a data compression algorithm as well as your KMS keys that Firehose can then leverage to encrypt the data as it is delivered into your S3 bucket. So now let's dive into the details of the service to understand how it actually works under the covers. A single delivery stream that you create can deliver the data into a single S3 bucket. You can control the size of the S3 objects and the frequency at which they're delivered into the bucket by using the buffer size intervals. The buffer size can range from a megabyte to 128 megabytes, and the buffer interval can range from 1 minute to 15 minutes, specified in seconds. The buffer operation itself can be thought of as a concatenation operation. So as you put hundreds of thousands of records into your Firehose, based on the buffer intervals and size set, Firehose will concatenate or buffer up the individual records into a single larger S3 object per the defined criteria. As the condition comes true, it triggers the actual put into the specified S3 bucket. So depending on whether the buffer size condition or the buffer interval condition comes, whichever condition comes true first, Firehose will trigger the put into your S3 bucket. Data can also be compressed, and the compression is applied after the buffering of the data. Specifically, you can pick from gzip, zip, or snappy compression algorithms. And please bear in mind that since this compression is applied after the buffering stage, the final size of the S3 object delivered can end up being smaller than the aggregate data that was put into Firehose on that same interval of time. As we saw in the console, Firehose needs an IAM role to access your S3 bucket. And more specifically, the delivery stream will assume the role that's specified in the IAM policies to gain the right set of access permissions to your target S3 bucket. Optionally, Firehose enables encryption of data using AWS Key Management Service. For those of you who do not know, KMS, or the Key Managed Service, is a fully managed service that enables customers to create and control keys used for data encryption. KMS itself uses hardware security modules to protect access to the keys themselves. Firehose specifically will pass the KMS ID to your S3 bucket and leverages the existing S3 encryption for KMS to encrypt your data. S3 service uses the bucket and the object name as encryption context to then encrypt your data as it is stored in the target S3 bucket. Because Firehose is performing this buffering and continuous putting on your behalf, there is a specific object name format or pattern that you should be aware of. Firehose by default adds a UTC time prefix of the format of year, month, date, hour before the objects are put into S3 itself, where each / is effectively a subfolder. When you specify the optional prefix, you effectively get your own top-level folder. To do that, you can add your prefix name followed by a / to get a format that looks like the name of your prefix / year, month, date, hour, all separated by /. If you simply want to prepend some text without necessarily introducing another top-level subfolder, merely drop the / and just enter your prefix. When Firehose starts delivering data into your S3 bucket then, expect the following naming pattern. The name of your delivery stream, hyphen, the version number of your delivery stream, hyphen, year, month, date, hour, minute, second, followed by random GUID. The delivery stream version is set to 1 when you first create your delivery stream and assuming that you make no changes to your configuration after you've created the initial delivery stream. Each time you change your configuration, for example, let's say you increase the buffer size from 5 minutes to 15 minutes, or you changed from no compression to gzip compression, Those changes to the configuration result in your delivery stream version number being incremented by 1. Understanding the naming pattern is important because you might have downstream data processing workflows. Perhaps you're using Lambda to consume from your S3 bucket triggered off the put notification. Perhaps you intend to run Hive queries against that S3 data. Maybe you intend to run a Spark job. And all of those processing next steps that are happening in near real time, as soon as the data lands in S3, will probably need some prior knowledge of the naming pattern to know how to parse out the files and then to take your business-specific action. Now, what happens if Firehose is unable to reach your S3 bucket? Now, this could happen for a variety of different reasons. Let's say that configuration permissions were changed such that Firehose is no longer able to reach your S3 bucket. Firehose will try to access the bucket every 5 seconds until the issue is resolved, and you get peace of mind that Firehose is durably storing your data for a period of 24 hours. And Firehose resumes delivery of data as soon as your S3 bucket becomes available and it starts to catch up. But please be aware that if your S3 bucket is inaccessible for more than 24 hours, then data can be lost. Later on, we'll cover the variety of different metrics that Firehose exposes that you can then set metrics, alerts, and alarms on so that you can know that there is a problem in terms of Firehose delivering data in your S3 bucket, and you can be alerted to take corrective action as quickly as possible. Let's shift gears now that you have the high-level basics of how Firehose delivers data into S3, and talk about the mechanism for Firehose to Redshift before we step into deeper details. The Firehose delivery into Redshift is a two-step process. Step number 1 is to actually use your provided S3 bucket as an intermediate destination. So everything we've learned so far still applies. Using S3 bucket as an intermediate store is still the most efficient way to do efficient data loads into Redshift, and it's a way of ensuring that data is always durably stored in your S3 bucket so that you can access it and is always present even if, for any reason, your Redshift cluster is unavailable. The second part of the data loading process is for Firehose to issue a copy command that you have provided as part of setup to do synchronous copies of the data that has been staged into your S3 bucket and to load it into your Redshift table. Let's look at some details now. From a console perspective, you'll notice that the Firehose to Redshift console is a simple extension of the Firehose to S3 console, wherein the details of the intermediate S3 bucket as well as the details of the Redshift cluster can be provided quite simply within the console itself. All of you can try this right now on the Amazon Kinesis Firehose console. But most of you probably want to know the specifics that surround the delivery of Firehose data into Redshift. As we learned, your S3 bucket is used as an intermediate destination, and Firehose uses your provided copy command to synchronously load data into your Redshift cluster. More specifically, a single delivery stream loads data into a single Redshift cluster, database, and table. So a single delivery stream to a single table is a fundamental mapping. When you think about then the frequency of loads into your Redshift cluster, as you've probably realized by now, when using S3 as an intermediate destination, the time that is spent either on the explicit buffer interval or the time needed no more than 15 minutes for building out the size of the buffer is the minimal amount of time that will be needed before the copy commands get executed. Another way of saying this is that Firehose delivery to Redshift will be greater than 1 minute strictly, and in most cases will be greater than 5 minutes. Now the Redshift copy command frequency ultimately dictates the frequency of loads into your cluster. Let's assume that data is being continuously captured, buffered, and delivered into your S3 bucket. Firehose will issue the copy command after it gets a successful acknowledgement from your Redshift cluster that the prior copy command executed. And so depending on how your Redshift cluster has been provisioned and how much load it is currently under, the actual frequency of the copy command will vary. For efficiency purposes, Firehose uses a manifest copy mechanism, and the intermediate S3 bucket will contain a manifest folder that will hold the list or the manifest of files that are going to be copied into Redshift. Firehose employs the Redshift copy command with zero error tolerance. So what we mean by that is if a single record within the compiled S3 object or file fails, then the whole batch of files within the copy command will fail. So Firehose will not perform a partial file or a partial batch copy to your tables. As a result, all skipped objects information is captured and delivered into an errors folder into the target S3 bucket. Now let's say that your Redshift cluster is not accessible. Firehose will try to reach your cluster every 5 minutes for a total period of 1 hour. If the cluster is still not reachable after 60 minutes, Firehose will skip the current batch of S3 objects that were scheduled to be moved and will simply move on to the next batch of objects. And like before, objects that are skipped, information, the metadata as well as the data itself is delivered to the S3 bucket as a manifest file in the errors folder. And under those circumstances, you will have to undertake a manual backfill process as appropriate. But Firehose will focus on ensuring that data isn't lost, and B, that the most recent data is delivered into Redshift first. So now that we have some of the basics out of the way, how do you put data into Firehose? There are a couple of different ways to do this. The first way is to use the Amazon Kinesis agent, which is software that makes submitting data to Firehose easier. The agent monitors files and sends the new data records into your delivery stream. It performs a reliable, timely puts on your behalf and handles things like file rotation, checkpointing, and best practices requests and retries on failures. It also emits CloudWatch metrics to help you better monitor and troubleshoot the overall streaming process. By default today, the agent is supported on Amazon Linux Armies as well as Red Hat Enterprise Linux versions, and you can install it via a simple sudo yum install command today on your EC2 instances. And you can use the agent for server-based environments like web servers, front ends, logging servers, and more. The agent is also enabled for Kinesis Streams should you decide to put data both into Firehose as well as the Kinesis Streams endpoint. There are other ways to interact with Firehose as well, beyond the console and beyond the agent specifically for putting data into Firehose. The entire Firehose API can be encapsulated on this single slide. Like with most services, you can create and delete your delivery streams, as well as describe an individual delivery stream and list all the delivery streams that are available under your account. Updating the destination or the update destination API is a specific API that you can use to update things like the buffer size, buffer interval, the compression algorithm you want to use, as well as change or add a Redshift cluster that you might want to deliver data into. In terms of explicitly putting data into Firehose, there are two APIs, the put record and the put record batch API. The batch API enables you to put up to 500 records or 5 megabytes of data in a single API call into your delivery stream. As before, limits apply on the maximum size of a single data record, which is no larger than 1,000 kilobytes. In terms of Firehose pricing, there is only a single dimension. It is a purely pay-as-you-go model, which means if you do not put data into Firehose, you do not pay for Firehose. Firehose is billed at 3.5 cents per billable gigabyte of data ingested into it. Now with the basics out of the way, let's spend a little bit of time diving deep into the metrics that Firehose offers and what it means to troubleshoot your Firehose to S3 or to Redshift under different scenarios. Let's start by doing a quick review of the key Firehose metrics that are specific, in some sense, for the Firehose loading to S3 mechanism. Firehose will emit an incoming bytes and incoming records metrics, which is simply the number of bytes and records that have been ingested into the delivery stream. On the opposite side, if you will, Firehose also emits a delivery to S3 bytes and delivery to S3 records metrics that computes the number of bytes and records that have been delivered into S3. There are also two unique metrics that Firehose emits. The first one is the delivery to S3 data freshness, which helps you understand what is the age of the oldest record in the Firehose. So using that number, you can understand, you can come to the conclusion that for any record that is older than this has indeed been delivered into your S3 bucket. The other unique metric is delivery to S3 success. This metric simply computes the ratio of the sum of all successful S3 puts that Firehose executes on your behalf over all S3 puts that Firehose has executed. This lets you get a quick sense for, are Firehose puts failing such that data is not being delivered into your S3 bucket. There are some analogous metrics present for loading data to Redshift as well. There's delivery to Redshift bytes and records, which is the number of bytes and records that were respectively copied into your Redshift table. And similarly, there is a delivery to Redshift success metrics, which computes the sum of successful Redshift copy commands over all Redshift copy commands executed. Now, with those basic metrics and all API-related metrics, which are also available on the console, let's try and see if we can help answer some questions that you might find yourself posing to yourself as you begin using Firehose. One of the first questions that we notice customers typically have is my data flowing end-to-end? From the data producers through the delivery stream and into your S3 bucket. As we learned, the key metrics you want to keep an eye on are the incoming bytes and incoming records, along with their analogous metrics on the delivery side, and more specifically in this case, using the delivery to S3 success or delivery to Redshift success metrics. Help you get a quick sense for the data help you get a quick sense for is the data actually flowing through the Firehose end-to-end. Additionally, as we mentioned, all of the API metrics are also available, so you can check the put APIs, bytes, requests, latency metrics to determine if actually the puts are executing into your Firehose or not. Next, you might want to keep track of what is being captured and how much data is being delivered into your destination. In this case, you want to have a look at the put records, bytes, and requests, as well as to get a sense for how much data is being captured on ingress by the Firehose. And next, you can check the delivery to S3 bytes and records or Redshift bytes and records to see if the data that is being put is being indeed delivered into the destination, S3 or Redshift. You can additionally check your S3 bucket to see if the data and the objects are indeed being delivered, as well as checking on the volume itself. And you can also verify this on incoming records and incoming bytes. As we learned earlier, please bear in mind that if you are using compression options inside of Firehose, then what is delivered is typically smaller than what is captured by Firehose because of the compression in place. The next question you might have is my data showing up on time? And you want to make sure that Firehose is indeed delivering data in a timely way. As we heard before, Firehose to S3 has a minimum latency of 60 seconds or 1 minute. And a quick way to check is to look at the delivery to S3 data freshness metric, which in seconds will show the maximum age of the oldest record in Firehose that has not been delivered into your S3 bucket. So you can conclude from there that any record that is older than this age in seconds has indeed been delivered into S3. Here's another troubleshooting scenario. Is something going on with my Firehose, or is it really the target S3 bucket or cluster? So what is going wrong? The S3 and delivery to Redshift success metrics, which computes the sum of puts or copies over sum of all puts or copies, is a useful place to start. If this ratio is trending below 1, it suggests that there are potential issues such that the Firehose put into S3 is failing. And at that point, it is normally a great place to work on to understand if the S3 configuration has failed or if something has gone wrong. Similarly, for your Redshift cluster copy, if that metric is trending below 1, it would imply that that the Firehose loads into Redshift are failing. What are the key steps that you should take if you notice that your data isn't showing up in S3? First, we should start by checking incoming bytes and records metrics to ensure that data is actually being put into your delivery stream. The next thing is to check the delivery to S3 success metric. to ensure that Firehose is actually putting data into your S3 bucket. You must check that the S3 bucket that is specified in your delivery stream when you are configuring it, in fact, does actually exist. Because S3 buckets tend to be shared resources by potentially multiple people in your organization, you might want to create a specific bucket for the purposes of Firehose delivering data. Similarly, and it is always important to ensure that the Firehose permissions as specified in the IAM policy are always up to date to ensure no break in continuity of access of Firehose to your S3 bucket. So how about some key steps if your data isn't loading or showing up in Redshift? Redshift being a provisioned resource where with potentially multiple different simultaneous users loading and or reading data from by directing queries at it can become a contentious resource. Per usual, start by first checking in incoming bytes and records to ensure the data is put successfully. Because Redshift delivery uses S3 as an intermediate destination, check the delivery to S3 success metric to ensure that data is making its way into S3, and you can further verify by checking the S3 bucket itself. Next, check the delivery to Redshift success metric to ensure that Firehose is indeed succeeding in copying data from an S3 bucket to the cluster. As before, ensure that the Redshift configurations as specified in the Firehose are accurate and up to date. And Firehose uses the Redshift STL load errors table to verify the reasons of the copy failure. Please recall that Firehose copies or executes the copy command in a all or nothing manner. So even if a single file, record in the file, or files in a batch fails, the entire copy command will fail to execute, and it will place the manifest as well as the files themselves into the errors folder. And by checking the load errors table, you can dive deep and understand the actual reason for the copy failure. Some of you who have used or are planning on using Firehose are also aware of Amazon Kinesis Streams. Amazon Kinesis Streams was the first service in the Kinesis platform that we launched 2 years ago. When you wish to build custom real-time processing applications and you want complete control over how you partition your data, and you want complete control in how you scale the stream in response to incoming data, and let's say you want to apply your choice of a stream processing framework to build multiple applications of the same Kinesis stream, then the Amazon Kinesis Streams service enables you to do precisely that. Firehose is a fully managed service that enables you to capture and deliver your streaming data into destinations like S3 and Redshift, while still bounding the overall latency in the few minutes range, but enable you to use your existing tools, your existing analytics processes that are already snapped in with S3 and Redshift without having you write net new applications or managing different resources. Several customers have started with Kinesis Streams and have built one of their applications, say something like a Lambda function, that pulls data from Kinesis Streams and then egresses it into their target Firehose, and they get the best of both worlds. They can continue to build real-time applications using their framework of choice with Kinesis Streams while allowing Firehose to do the data delivery and loading into S3 and Redshift. That brings us to the end of the planned slides. And now we are ready to take and tackle all the great questions that you've been sharing with us on Amazon Kinesis Firehose.
Great. Thank you, Eddie. And audience, thank you for submitting all the great questions. I'm sure Praveen has already provided most of the responses to you, but I'm sorry if we cannot get everyone's question. But right now we have about 15 minutes left. Please feel free to continue submitting questions. We will utilize this time to give more one-on-one attention to everyone, and Eddie will answer those questions verbally. So to the left, if you can see, there are 3 poll questions just opened. If you can let us know your feedback of today's webinar, it will really help us improve our webinar programs. So now I'm going to pass the floor again to Eddie, who are going to start answering questions.
One of the key themes that we're seeing in the great set of questions is on the interplay between Kinesis Streams and Kinesis Firehose. For all practical purposes, these are 2 different endpoints, 2 different service offerings that deliver distinct value for different sorts of use cases. If you want to start from building a real-time processing application first, then the place to start would be with Amazon Kinesis Streams. And because Streams enables you to have multiple different custom-built, unique consuming applications, one of those applications could be a relatively simpler application that pulls data from the Kinesis stream and then turns around and emits it into your Firehose. And the remainder of your applications can focus on building real-time applications. There's another very specific great question around the concatenation operation and the load into Redshift, the behavior therein. Now, as you know, the Redshift copy command, for example, works great with non-nested JSON and is able to infer and load the schema into the corresponding Redshift table. The Firehose buffering or concatenation operation does not in any way change the structure of the individual records. So let's say that you're putting JSON or CSV data into your Firehose. The buffer operation is simply just that. It will load the batch of records into your S3 bucket such that your Redshift copy command can then take, say, the JSON or CSV files and map them directly into the Redshift table that you want to direct the data into. There's another question on Firehose to Redshift, which is really around changing the frequency and times the Redshift copy command is retried. That's a great question, and we don't have specific knobs and optionality to specifically control that. As you mentioned, right now it is the Firehose design point is one around recency of data and to make sure that data is not lost once put into Firehose. So it will behave in a manner where for a period of an hour it will continue retrying on a 5-minutely basis until that hour-long window expires. But we're certainly open to feedback that you might have on how we should think about a more configurable retry policy for loading data into Redshift. I just want to acknowledge another specific theme that we've noticed, which is doing performing some variety of, if you will, pre-processing on the data, pre-processing the data captured by Firehose before it's loaded into S3 or Redshift. I think that's a great piece of feedback and something that we're hearing loud and clear, and we'll work hard to go figure out the best way to expose that in future releases. Another question on plans to support multiple other targets like DynamoDB, RDS, Elasticsearch, so on and so forth. We absolutely intend to do that. With Firehose, you want to make it easy for you to capture and then deliver data into multiple pertinent destinations. Each destination brings with it its own specific set of needs that Firehose will help tackle and deliver. And that's kind of our goal here. There's a question around the Kinesis agent about RAM, CPU, disk size, and guidelines. So we have tested the agent to be a low CPU overhead piece of software. Having said that, your mileage may vary. You might have a big box, a bigger EC2 instance that is generating a ton of data that you wish to capture with Firehose relatively quickly and minimize buffering on that EC2 instance. In those cases, the CPU utilization can increase, but we've tried to keep it to a low single-digit percentage of the CPU resources available on the given EC2 instance. There's another question on Firehoses, if it works in only a single region in terms of other resources. You can absolutely create a Firehose in the US East region and have it deliver data into a bucket in the US West 2 region, for example. So that is absolutely possible. There's a question around Firehose streaming data to Redshift without using S3. Currently, our implementation uses S3, and we still think it's that there are benefits to doing that, both from a performance perspective as well as making sure the data is available and accessible to you for any other reason, including you might want to run some other process on the same data that's captured, as well as give you the guarantee and assurance that should your cluster be unavailable for any reason, your data is still present. So there's a question on the Kinesis agent. So there is a unified agent that puts data, that can put data both into Firehose and Kinesis Streams, and we have updated our developer guides to reflect both of the operations. There are several questions of a variety that are really more around roadmap. Um, Arguably, it's going to be a little hard for us to talk about what future instantiations of Firehose and what future features will look like in this specific forum. It will be great if using the Q&A forum you can actually share what you might want to see, um, and that will really help us and the team in prioritizing how we should think about the next set of features for Firehose. But unfortunately, in this specific forum, it's a little harder to talk about the specific enhancements that we might have underway. There's a question around a potential mobile app that might generate hundreds of thousands of events per second, and and the question was, I believe, around sending these events to the agent for uploading into Firehose. So conceptually, yes. The specific here, though, is that the agent is not a mobile target. The agent is based on, for server-side environments. Um, if you have mobile apps that you wish to integrate with Firehose, then the way to go would be using the AWS Mobile SDK that exposes the Firehose APIs that you can then which you can then use to integrate with. There's a very specific question around having used Firehose for Redshift and there being um, and the request is really around exposure of logs and what does it mean if there are no load errors and your delivery to success was zero. That seems like a very specific question, and I would love to hear from you directly, ADIKRI at Amazon.com. And so you can feel free to email me so that we can help figure out and get to the bottom of that specific question. So there is a use case question around collecting temperature data from sensors and controls to monitor and alert with Kinesis. There are several customers who use Kinesis for that use case. You know, the key thing here is what you intend to do with that data. If you want to build your real-time application for alerting and monitoring, and it's truly real-time, then you should probably use Kinesis Streams, perhaps in combination with AWS IoT. If your goal is to make sure that you want to capture all the data, send it to S3, and use Redshift for analysis, then and not have to write an application at all, then perhaps a great way for you to get started and roll into production would be with Firehose. There's another question on Kinesis Streams having announced optional 7-day retention and the support on Firehose. The answer is not yet. Firehose still operates on a 24-hour durability window. There is another question focused on how does data collection work. Like with most AWS services, data is put into the Firehose endpoint. As we explained, you can use the agent, you can use our API set, or you can use the AWS SDK, which provides a neat wrapper around the APIs. So that would be how you put data, using the agent, using the AWS SDK, using the AWS mobile SDK, or directly by interfacing with the put APIs. There's another use case question really around suitability for video and audio streaming. Just to be clear, Firehose is agnostic of the data type itself. We don't know, and Firehose doesn't care if you're putting clickstream data or financial services data or social media data or advertiser data. It simply sees byte arrays. And since the purpose of Firehose is to then capture and deliver that data in near real time to S3 and then to Redshift, if your data is of the kind that does not need to be either stored in S3 or cannot be analyzed with Redshift today, then that kind of data may not be the right fit for Firehose. There's another question more on putting data into Firehose, which is the log rotation pattern. We have the Kinesis agent, and we talk in some detail about how log rotation works, and that would be arguably a great place to start to understand, what patterns you want to use to rotate data, rotate your files on your boxes as you put them into Kinesis. There's a question around buffering characteristics about guarantees around complete records in the buffer, which I think has already been answered by my colleague Praveen. There's a question, the last question that I'm going to take is really around being able to use Kinesis against data stored in some other destination, like RDS and such. And the way I'm parsing this question is that it's similar to what are the different destinations that Firehose supports. And as I said earlier, we intend to support many destinations, and we'd love to hear more from you about what those destinations should be and how we should, and that will deeply inform the way we prioritize.
Thank you, Adi, for your time and a great presentation, and audience for staying with us right now, and also Praveen for answering questions throughout this presentation. So if you have any comments on previous and upcoming webinars or suggestions on the topics which AWS may cover in future webinars, please feel free to email to aws-webcasts@amazon.com. Again, it is aws-webcasts@amazon.com. Your feedback helps improve our webinar programming. Thank you to our audience. Our day 1 of October series is over right now. Enjoy the rest of the day.